In this video, we're going to talk about one of the most important classes in Java when dealing with collections of values, which is the main topic for this class. And the class is called the ArrayList Class. For starters, we need to understand that the ArrayList class provides an implementation for a Java interface, which is called the Java List interface. Java has a way of defining collections of values in different ways. One of the ways it does so is by the so-called the list interface. There will be another video called the list interface video that you should watch eventually, but at this point it's not crucial that you know. The only thing we need to understand at this point is that there is an interface in Java called list, and one way of implementing that interface in Java is by using the predefined ArrayList class, which we're going to discuss today. I could take a look at the Java List Interface API, so let's do so. As you can see, I have pulled the Java interface list from the Java API on my screen. And this is the version 8 of Java that I'm using today, but this class, this interface exists in previous versions of Java. So if you don't have access to the Java API for version 8, that is completely fine. So you're going to see that the name of the interface is called list, and you should know by now that there is a difference between an interface and a class. An interface basically is just a set of specifications. A class is a particular implementation of a model. So I'm going to show you in a couple of minutes the corresponding Java API for the ArrayList class, but this is the Java API for the interface list. And the first thing to notice is this E in angle brackets, and that simply says that when you create a list, which is a collection of values, you have to use this symbol and replace the E with the type of the elements that you're going to have in the list. We are assuming that the collections of values that we have on the list, they are all of the same type. They are all string objects, or they are apples, or they represent information about students or flights information. So this E will be replaced with the type that we are using in the collection. I'll show you a couple of examples later on. So what I want to concentrate is in some of the methods, and you can see as I'm scrolling here, there is a large quantity of methods that needs to be implemented, and I'm going to just concentrate in a couple of them that I will repeat. So here we see that there is a way to add values to our collection, and again this E, capital E, represents the type of the object, whether it's a string or a color or an integer value, or represents student data, and then E is the actual value of the object. And there are two versions of the add. I'll explain those when we see the differences, when we see the Java implementation for the class. And then there is a clear, there is a contain, which is basically a search. There is an equals that allow me to compare values. There is a get that gives me access. Given an index, I can access a particular element. There is going to be two versions, or at least, of remove. Remove given an index, remove given a particular value of an object. And then the other two that I want to discuss are the set, that allows me to change the value. So if you give me a new object and a location, that will replace that value in my collection, and then size, which is very important, that gives me the numbers of elements on the list. Now I'm going to switch to the class ArrayList, and now notice that the word class is not interface anymore, and we still have the angle brackets, and again we need to specify what kind of objects we're going to have on the collection. So the first thing to understand is that the ArrayList is basically an array, and as any other array in Java, is an array of references, and those references can only have two values. Either the reference referred to an object of whatever class we want to represent in our collection of values, or it has value null. Okay, so the ArrayList is an array of references, and each of those references has one of two possible values. It's either null, which means it's not being used, doesn't refer to anything, or it refers to a particular object that we have stored in memory. So let's go through the methods as usual. It has a constructor. So the basic constructor is to say ArrayList. Remember that constructors has the same name as the class. And in Java, notice that the initial capacity is 10. That means it creates an array where you can store 10 objects. And after that, we can increase the size of the collection as needed. Obviously, 10 is a very small value for a real collection of values, but Java will take care of increasing dynamically, so we don't have to worry about how to increase the size of the data. So the first two methods that we see here are add, given an object, and add given an index and an object. And basically, as you can see here in the Java API, when you add a value to an array list, what it does is to append, which means it adds at the end of the collection. So there is no need to specify the location for the new object. The new object will be appended at the end of the existing list. The second version of this add requires two parameters. The second one is obviously the element that we want to add, very similar to what we have here, but now this gives us the capability to decide the place of insertion. So instead of appending at the end, as this add does, we provide a particular index. And as long as that index is a valid index for our collection, then it will insert the value at that particular position. Notice that this is a complex operation. If you really think about inserting values into an array given a position, that means that some elements will have to be shifted toward the end of the array so we can insert the value. But because this is a Java class, all those details are taken care of. So as long as we provide a valid index and the value of an object, everything will take place normally and as supposed to be. Notice also that in these two adds, we don't worry about the size of our collection. So these two methods will take care of increasing the size of the array, increasing the size of the collection as needed. Remember that we start with a capacity of 10, so we're talking about a real collection, we're talking about thousands and hundreds of thousands of elements. So these two adds will create a new array and copy the old values and increase the current size of the collection. The next method I want to discuss is contains. Contains is the word for search. And again, we're going to provide a particular object, the value, right, that we're searching for, and it's going to search the array. And obviously, this is going to return true or false, whether or not the object is being found. The next method is the method get. And remember, any methods that start with get in Java is what we call an accessor. It gives us access to a particular value, to a particular element. And in this case, we provide a valid index, right? And this is going to return the element at that position in our array. So it returns an object. And again, we use this E, and again, E is whatever the type of the object we have in our collection. So it's the same E that I was referring to up here. Okay, so that means if we have a collection of strings, E is a string. We have a collection of, let's say, a student objects, that E will be a student object. Okay, so let me scroll down back to where we were, and the next method is going to be set. Okay, and again, this is, again, in Java, there are a whole bunch of collections of methods that start with set. And we know that this means mutators. We're about to produce a change. We're about to change the value of one of the objects. So in this particular case, we are going to provide a valid index in our collection, and the object at that location will be replaced with this new value. It returns the value of the element that has been replaced. So this is a way of changing the value of a particular element in our collection. So to change the value, we need to know its location, the index, and then the element. Finally, we have the method size, which obviously returns the numbers of elements in the list. It's very important to know for different operations how many elements we have in the list at any given time. And that obviously, this method returns an integer because the size is an integer. I encourage you to take a look later on at the Java API and go through the methods and see all the functionality that is provided to you in the class ArrayList. It's very important to realize that we're talking about an array list, so we need to think in terms of indexes, elements that have indexes. That's why some of the operations like the add and the remove will require an index in some instances, and definitely the set operation will require a particular index. So we had seen both the API for the list interface and the API for the ArrayList class. So let's talk about some other features. Here are some examples about using the ArrayList class. So the first step, of course, is to create an object to represent my collection, my array list, and that's done as we typically do in Java. So I need to use the word array list, which will have access to the class we just discussed. And here is again the angle brackets that we discussed before. So the is has been replaced now with a specific class. In this case, I want a collection of strings, and I'm going to call that my list. And then in order to allocate memory as usual, I'm going to call my constructor. And again, I need to specify that it's a constructor in the ArrayList class, and I want to create strings in my collection. This could be done in one statement, but I split it into two. So this creates an array list called myList, and remember the constructor starts with 10 elements. So right now I have a capacity to store 10 strings. One way to add the strings to the list is basically by using the add method. So here are 3 examples. And notice I'm doing something a little bit strange. I'm adding a number, a numerical value 50, followed by 2 strings representing name of states here in the United States, California and Oregon. So it's a little bit odd that I'm adding different type of values, right? One is a numerical value, the other ones are sequence of characters, strings representing United States states. This is just to show you what kind of things you can do. Obviously, this doesn't make any sense. It's not an error. What is going to happen here, and I will explain this later, is that the 50 is not added actually as a numerical value. 50 is added as the string. So Java automatically, behind the scenes, will do some conversion. It will convert this numerical value into a string that has 2 characters, the character 5 followed by the character 0. So in a way, I'm consistent with my declaration when I said I want a collection of strings. I want every element of my array list to be a string object. So Java is going to do automatic conversion of this 50 into the string 5 followed by the character 0. Because I'm using add, every one of these 3 values will be appended. So the first value in the collection is 50. The second value in the collection will be California. The third value in the collection will be Oregon, because add, it just appends, adds the new value at the end. What would happen if I add 20 values? So the collection started with 10, so when I add the 11th value, Java, the add method will recognize that I started with 10, I'm trying to add an 11th, and it will resize the size of the array and allow me to insert more than 10 values. One way to use the method get is by simply again having the class myList and then get1, and as long as I provide a valid index, I will not get an exception, I will not get an error. So this is a valid index because so far I have 3 elements. So this will print California because California is the element that has index 1. If I want to change the value, I can use the mutator set. And again, remember, I have to provide, again, a valid index. In this case, 2 is a valid index that gives me access to Oregon. And now I'm saying, okay, the new value is going to be Nevada. So my collection now has the string 50 followed by California followed by Nevada. The method size works the way we expect. This shouldn't be a 2. This has to be size, okay? No parameters. And this gives me just the numbers of elements. So the value stored in this integer will be 3 because I have 3 strings in my collection so far, 50, California, and Nevada. There are 2 versions of the remove okay, as we saw in the Java API. I can remove by providing an index, and again, I need to provide a valid index. So this says remove the element that has index 1. Okay, the element that has index 1 has California, and so now my collection has been reduced to 2 elements. The first one will be 50, and the second and last one will be Nevada. California has been removed. Another way would be to say remove a particular value. So instead of an index, I could say remove Florida. And Florida is not in my collection because my collection has 50 and Nevada. So this is not going to alter my list. I don't get any error, simply it just does nothing. But if I were to provide an existing value in my collection, then it will do the things that we expect. What are those things? Well, remember, if you have an array and you remove a value, all the values in the collection, all the values in the array after the one that is being removed have to shift to the left, have to shift to the front of the array. And obviously the size of my collection will be changed because I am removing a value. There is a second version of the add, as you saw in the Java API, and instead of appending, we're allowed to specify a location. So here I'm saying insert this object at the beginning because index 0 represents the beginning of my collection. And then I have to provide what's the value of the new object that I want to add to my collection. So in this case, we'll put Florida as the first value in my collection, followed by 50, which is what I have, and then followed by Nevada, which was the value that I changed. And again, I'm inserting at the beginning of the array, right? So what happens when you insert at the beginning of the array? Well, all the elements that exist in my collection prior to this insertion will have to shift to the right, will have to be copied to the right toward the end of the array so that I can insert the new value in the first position. All the operations that the remove and the add require, meaning shifting values to the left or shifting values to the right, resizing the size of the array, all those are part of the implementation of the add method and the remove method as expected. So now let's talk a little bit about what Java does behind the scenes, and it has to do with this add 50 that was very strange. There is something called auto boxing and auto unboxing in Java, and Java does those things automatically. When I say my list.add50, remember that my list has been defined as a collection of strings. Well, 50 probably it means to us the numerical value 50. There are no double quotes around 50. But what Java is going to do is going to convert 50 into a string object because the definition of the array was to be an array of strings. So let's go back here, right? So we're specifying that the array is going to be an array of strings. This is what we're trying to do here. So I can only have strings. So Java is going to figure out that that is what we want to do. We don't want the number 50, we want the string 50 that has 2 characters, the character 5 and the character 0. So Java does that completely automatically, and this is what we call auto boxing. Okay, auto boxing in the sense that Java then creates, wraps a value with a class when it is needed. So in this case, it's going to take the value 50 and wrap it around, convert it into a string object. We call this, again, auto boxing. Okay, the reverse process will be something like this. Again, remember, my list is a collection of strings, so I'm going to use the method get that will extract one object, that means one string from my collection, and I'm saying, okay, give me the first string in the array, give me the first string in the collection. So this thing here, okay, this statement on the right hand side of the assignment operator is returning a string object, because get will retrieve an object from my array, my list, and my array, my list, has been declared as a collection of strings. So this extracts the first string in the array. Now, what's going to happen here? Well, we're talking about 50, right? That was the first value that we added. So now Java says, oh, I have now an object of the string class that has two characters, 5 and 0. And you are assigning that to an integer. That's what I want. So what is happening here is the reverse process of what we described before. Then Java is going to say, oh, I understand what you're saying. That 50, really, you don't want the string value, you want the numerical value. So Java is going to try to convert that string into a numerical value. Now, be careful. This may or may not be possible, okay? What would happen if the value that we have in index 0 is not 50? Let's say that it's a real string, for example, Pennsylvania, or New York, or New Jersey. So what is the numerical value of those? Well, that may not be possible. So we may get an exception, we may get an error. In this case, we know that we intentionally added something that represents a numerical value that was converted by Java into a string object. So now it wants to reverse the process. So when we say get 0, we are getting first the string 5, 0. And that string can be converted into a numerical value, which happens to be an integer. Java is automatically reversing the process. We sort of created a box around so that we can have a string object. Now we want to take that box and destroy it and extract the value so that we can store that into a primitive integer. Remember, x is a primitive, it's not an object. Integer is a primitive type in Java, so this x is not an object, so what we really need is an integer value, not an object of any particular class. So this is what is called auto unboxing. Through the different videos that you're going to watch for this class, I will be mentioning auto boxing is happening or auto unboxing is happening at this time, and that means these two processes that we just have described. It happens to be very useful. Otherwise, we will have to add several lines of code to do the manual conversion ourselves and have to do a considerable amount of testing. On the other hand, if we are not paying attention, Java may do auto boxing and auto unboxing when we don't want to. Now, let's understand what is in the ArrayList class, because this is going to be important when we do the analysis of the running time for the different methods we just discussed. There are many things that are provided inside the class, many fields, many pieces of data, but the most important are two. One is the ArrayList class provides, obviously, an array of references. That's what is called an ArrayList class. And remember, each of those references can only have two values. It's either null, which means it's not referring to any object, or it's referring to a particular object. In the example that we used before, it will be specifically referring to objects of the string class. And the second thing that is very important is that this class has an integer field that keeps track of the numbers of elements that we have on the array. So at any given time, we can use that field to determine exactly how many elements we have on the array. This is very important and this is very useful because what it means is that we don't have to count how many elements we have on the array when, for example, we're going to traverse the list. Or if we're going to delete the last element, we could find exactly where it is. Or if we want to add at the end of the array, we know exactly where to add because there is, again, an integer value that keeps track at any given time of the numbers of elements on the array. To finish this video, let's do some runtime analysis of the major methods. Because of that integer field that keeps track, the method size, running time, is constant, is 0.1. The 1 means that it's independent of the size of the data. So it doesn't matter whether the array has 100 elements, 100,000, or 1,000,000 elements. To calculate the size, the method size, is always constant. And why is that? Because there is an integer field provided by the ArrayList class that keeps track of the numbers of elements. So all we have to do when we execute the method size is to inspect that field. We don't have to traverse the list and count one by one, like in other data structures. that the getIndex method, the expected running time, is also independent of the size of the data, is constant. Why is that? Well, this is a property of any array. And because the ArrayList class is an array, if you provide indexes, then we can have direct access. As long as the index is valid, then we can have direct access to any element in the array. Same thing happens with set. Set depends on an index. And again, because we have an array, then we can use the indexes to have direct access to any element of the array. And again, the caveat here is that index have to have a particular value. So we have, so far, 3 operations which happens in constant time. 3 operations that are totally independent of the size of the data. That is very, very good. Now, when we do the add, any 2 versions of the add, we see that the expected running time is on. And again, let me remind you that expected means average. Okay, so in some cases, we're going to see that these 2 adds could be independent of the size of the data when we are in particular to the end. But sometimes we are going to add hundreds of elements at once, so we need to resize the array. And when we resize the array, we need to copy the old elements into the bigger array and then do the insertion. So the process of resizing the size of the array so that we can insert more elements and copying the values from the old array into the new larger array is what is causing the ON. The add without the index, remember that appends, inserts at the end. So you need to keep in mind that sometimes we run out of space, so we need to double the size of the array even when we are adding at the end. And obviously, the one with the index means that some elements are going to be shifted. So the running time is on either because we're trying to insert an element in some place in the existing collection and we have to shift some elements to the right, or because we have to increase the size of the array. Now, remove, again, is a similar analysis. The expected, the average running time is ON because we're shifting elements to the left to the beginning of the array when we remove a particular value. And it doesn't matter whether we remove given a value or we remove given an index, it's the same operation. Some elements are going to be shifted to the left, so they need to be copied, and on the average, that's going to be ON. But remember, there are very specific cases for these 4 methods in which the running time will be exactly constant and will be independent of the size of the data. But the expected running time is going to be N. So if we take a look at these values, we have 3 operations which are constant time, the set, the get, and the size, and the add and the remove, which are operations that we do, are ON. So as collections of data goes, this is a pretty good, efficient, reasonable data structure to use, and that's why we have the ArrayList class in Java.